Tutorial video on BGP Route Reflector, by Indian Cybersecurity Solutions. It is a method to get rid of the full mesh of iBGP peers in your network. Before we move on to the topic, we would like our viewers to subscribe to our YouTube channel and press the bell icon so you receive a notification on your devices when we upload our videos.
Hello everybody, my name is Debashish Roy. I'm the Senior Network Trainer as well as Cisco Networking Specialist at the Indian Cyber Security Solutions. And these are my contact informations for LinkedIn and Twitter. Today I'm going to talk about BGP Route Reflector. Now BGP Route Reflector is a concept which is used to reduce the full mesh iBGP peering between the BGP neighbors. So if you have the iBGP configured between iBGP neighbor routers and all the routers are connected to each other in a full mesh design, then the routing updates are more. They share more routing updates in a full mesh design. So to reduce the iBGP peering and to reduce the total volume of routing updates between the neighbor routers, we use the concept of BGP Route Reflector. Now the BGP peering connections means the number of connections, how many connections are there. It can be calculated using n into n-1 by 2 formula. Like for example, if you have 6 routers running in a iBGP peering, then in that formula you can derive as 6 into 6 minus 1 by 2, that is 15 peering connections. Now this is a route reflector diagram. You can see that there are say 1, 2, 3, 4, 5 iBGP peering routers, neighbor routers, and there is one router as route reflector inside the AS2, and one router is sending the routing updates, the routes to the route reflector, and the route reflector is reflecting or redirecting the route to the other routers. Say this is a function of the route reflector. One iBGP router sends the routing updates to the route reflector, and the route reflector redirects or reflects the routes to other iBGP peering routes or routers. So in this case, that I've already told you that this router is actually sending the route or routing update to the route reflector, and it's not sharing routes with any other iBGP peering. They are not connected with full mesh connectivity, and they are connected to the route reflector. This router is sending update to the route reflector, and route reflector is reflecting or redirecting that route, that routing update to other iBGP peering routers. So in this way, we can reduce iBGP peering. Now, there are some route reflector rules to be followed. Number 1, there is a route learned from a non-route reflector client, which is non-route reflector, which is not a route reflector capable client. This is advertised to route reflector clients, but not to non-route reflector clients. So there is a route reflector client who is reflecting route to the route reflector, and who is not reflecting route to the route reflector. That is the non-route reflector clients. So the route learned from a non-route reflector client is never advertised to the non-route reflector clients, but is advertised to route reflector clients. Second is, a route learned from a route reflector client is advertised to both route reflector and non-route reflector clients. And even the route reflector client that advertises the route, it will also receive a copy of its route, of its own route, but it will discard it because it sees itself as the originator of that route. Because if it accepts the route, then it will cause the routing loop. So to avoid the routing loop, what happens is that the route reflector client, if it sees itself as the originator of the routing update, then it will discard the route. Number 3 is, a route learned from an eBGP neighbor is advertised to both route reflector client and to non-route reflector client. So when a route is coming from the external BGP source, external BGP neighbor, then is advertised to both route reflector and non-route reflector clients. So this is actually the theory part for the route reflector, and now we are going to configure it using the GNSC simulator. So here is a simple topology where I have R1, R2 and R3, 3 neighbor routers, iBGP peering routers connected to each other inside an AS. and I'll configure R2 as a route reflector. So the concept is that R1 will send the routing update to the R2, and then R2 will reflect or redirect that routing update to that R3 neighbor. So first I'll configure interface IP addresses. So on R1, we are connected with fast Ethernet port. You can connect it through serial port also. Say the IP address is 11.0.0.1. On R2, IP address is 11.0.0.2. And on the other side, there is a F1/0 interface which is connected to R3. And say there is IP address is 12.0.0.1. And let's go to R3 now. Interface F1/0. And IP address is 12.0.0.2. Yes. So now the IPs are in place. So first I will make iBGP neighbor relationship, the normal neighbor relationship, the peering relationship. Say go to R1. Say router, BGP, and AS number say 1. All routers will be in AS1, and make neighbor relationship as neighbor as 11.0.0.2. Remote AS is also 1. And now go to R3. Router, BGP, and AS number 1. And make iBGP peering as neighbor is say 12.0.0.1. Remote AS is 1. Now you go to this route reflector, this R2, and you configure neighbor relationship with R1 and R3. Go to R2. P1 and neighbor is 11.0.0.1. Remote AS is 1. And now neighbor 11.0.0.1 space route reflector hyphen client. So that is a route reflector client, that is 11.0.0.1. Now it is up again. The neighbor relationship is established. And similarly, neighbor now R3 means 12.0.0.2. Remote AS 1 and neighbor 12.0.0.2 also route reflector client. So it has established a route reflector relationship with its neighbor routers R1 and R3. And now go to R1 and create a loopback interface. Say IP address is 1.1.1.1 and give subnet mask. And we have to advertise this network in the BGP process. After BGP1, and just as we advertise network, 1.1.1.1, you have to specify it, the exact number, and mask is 255.255. Now we have to check the configuration on the R2, the route reflector. On the R2, you just check with show IP BGP, then that advertised route 1111, and see if it's there. Yes, it is there, and the origin is 11001, is coming from the route reflector client. See, received from a RR client, means route reflector client, and 11001. Now you give this command, show IP BGP neighbors, and the neighbor is the R3, means 12002, and here advertised routes. Now I want to see how many routes advertised to the neighbor R3 12002. See, the iBGP neighbor relationship is established. iBGP route 1111/32, that is advertised to the neighbor R3. And now go to R3 neighbor, and here you give the same command, show IP BGP 1111, and see, yes, the route is reflected to the R3. See, the originator is 11001, so the originator is R1, who is the source, who is originating or who is sending the update to the route reflector, and we can see the route reflector ID as the cluster list. 12001 is the cluster list, means the route reflector ID. So cluster list is also used in route reflector in order to eliminate the routing loop. If the route reflector sees the cluster list ID as its incoming routing update, then it discards it to avoid the routing loop. So originator and the cluster list both are used to eliminate the routing loop in case of route reflector. In case of originator also, if the iBGP neighbor sees the originator ID as ID in the routing update, the incoming routing update, it discards it to avoid the routing loop. So we can view the originator who is originating the routing update and sending to the R2 route reflector, and route reflector ID is available as the cluster list. Cluster list means the route reflector ID. So this is the simple configuration for BGP route reflector that I have shown. So I have discussed with you the theory part and the practical part both, and I hope you have enjoyed it. I hope it was informative for you, and if you like this and if you want many videos like this, please subscribe our channel on YouTube. Please like it and also subscribe it to get more videos in future. So that's for today. I will come with some new topic on some other day. Till then,